Right. Go ahead, Dr. Madhavan.
Okay. So I'm a crusader, and my crusade is on what's called causality. So the key type in my title is beyond digital twin and IoT and AI. It is causality. I'm hoping by the end of this session, you'll join me in this crusade. The reason why I've taken on this crusade for the last 2 to 3 years now is because I believe causality is the next big thing in machine learning. Everything we do today, everything is really correlation based, and we all know the slogan, correlation is not causation. It's been hard to work with causality, but some improvements and advancements have happened in the last 20 years, and have personal experience of doing a startup in this area in the last 2 years. So I think the fear of causality is gone, at least for me, and I want to share that good news with everybody. My way of thinking about digital twin is that second bullet. I always have AI within quotes because I think of it as a marketing term, especially in industrial IoT. What we do really is machine learning. There is an aspect where there is natural language and image recognition, but that is not the area that industrial IoT typically focuses on. So I see digital twin as a convergence or a framework where just getting data through IoT is only partly the story. You have to do something with the data, and that is through machine learning. And the best framework for that is digital twin, and I'll talk about that. The third thing is IoT has been embraced by business. Lots of money has been spent, but it turns out that there is a small trough of disillusionment, another AI winter suspicion that is lurking. The reason is it produces great pictures in that, you populate machines picture on the screen with real-time measurements, and it's a great way of getting inputs to the human eye. But it does not really improve gross margins of the business. For that, you have to increase production, increase quality, reduce cost of goods sold for work. That the current digital twins are not able to do, and we'll visit that briefly. So what qualifies me to talk about these things? I won't go through this, but I've had lengthy experience in the appropriate industry companies like Rockwell Automation. It's the mother of industrial equipment monitoring. And GE Aviation, jet engine, we get continuous data. And as I mentioned, NEC, so about 2 years ago, I championed Causality startup and launched it, and it's been a big success. But it is in marketing side, so its application is different. And I have been doing work in data science from a different perspective. I approach it from systems theory rather than statistics, and published a book on it called Systems Analytics. So people seem to enjoy it, especially engineers. That is a very easy way to approach. Now going to causality, Judea Pro, that first name is the biggest name. He started this back in 2000 when nobody paid him any attention. But in 2012, 14, I forget the exact year, he won the Turing Award. So then the Nobel Prize in Computer Science. So he has become mainstream. You would have seen lots of press on causality in the last 6 months or a year. Bengio, one of the three amigos of AI, along with LeCun and the guy from Toronto, he has been talking publicly saying, well, look, we need to incorporate causality into AI, deep learning, otherwise we're going to run into a kind of a bottleneck. Friston is not a name any of you would have heard. He's a very accomplished neuroscientist in London. And he, again, starting 2000, has been applying very sound system theoretic principles to causality analysis in the human brain. So he has made significant progress, and his work is something very interesting to follow. So this sounds kind of technical. A part of it is technical, but I'll switch to the brass tacks. How do we use it? What is a business, etc. in the next few slides. And it's in the next 10 minutes for sure. So without spending a lot of time, I see there is a kink in the growth of IoT. I mean, we can do alarming and sensors and so on, but to actually create gross margin increases, less waste, higher quality, we need to move from predictive analytics to actually prescriptive analytics. And prescriptive analytics, in my view, requires causality. So that is the kink in the IoT growth curve. And if you don't solve that, we don't solve that collectively, I think we are going to enter into this trough of disillusionment, the famous Gartner picture here. Today in IoT, there is lots of development going on. So in one slide, I tried to bring all of that. There really is a kind of a bifurcation. There is a whole application of AR, VR for education training, significantly important. But my focus, and I talk about this, anyone interested, that article explains this picture much better. Our focus will be on this right-hand side and actually using it for what I call precision works, improving automation. And causal digital twin is the fundamental concept, and it is realized through a methodology called inverse modeling. And I have developed an actual working solution called what-if analysis, what-if digital twin, because there you can do what-if analysis and then show that you can do this, then this will increase, and that cost will fall. So then you can prescribe actions. So causal digital twin is not a different thing. It is an extension. Display digital twin is where there are these nice pictures where we are today. Major companies like ANSYS has been doing simulation digital twin. That is using either a set of differential equations or some other methodology, finite element analysis and so on. They can actually show heat maps on a motor and so on. But what they each do, for example, display digital twin is great for knowing the status of the machine. Simulation can help in identifying the faults. But when you have to prescribe actions, as we say, that's where the payoff is. We need causal digital twin. Why is that? And this is from Friston's article. This is a great way to think about it. If you had EEG taken, the picture on the right, you can see these squiggles, and people have correlated with alpha waves, you're calm, sleep spindles, you're sleeping, etc. That's correlation studies. But what they want to really know, the neurologist, is where is the focus of epilepsy, like the picture on the left-hand side. And that requires inverse model. This is what Friston has been working towards. In our case, the right-hand side, that's the IoT sensor data. What we really want to know is inside the machine, is the shaft bend? Is the bearing, in a race and the ball out of sync and so on. So we get surface measurement and you can visualize it great, but really what we want to know is underlying relationships. And so the forward problem or forward model where we predict the effects knowing the causes. But what we really want is we make these measurements and then we want to know the causes given the effects, the observations and the measurements. That's why it is something distinctly different. There is a big confusion about, what is this? Display digital twin, simulation digital twin, and people are confused. So I've spent a little bit of time talking about this here. So in the case of a motor, you'll have an accelerometer sitting there measuring, but these are the insides. On the right-hand side, it's a basic model. There are two bearings and shaft, and they are all vibrating. So the one on the top picks it up. But what we are really interested in is these couplings, K1, K2, K3, because the coupling changes, the way a motor will drive, whatever the pump, etc., will be affected. Then we know what to go and do an alignment of this spindle. So again, surface measurements, which is the vibration signal that you measure. I mean, there could be temperature, pressure, all kinds of things. Just take an example. What we really want to know is the underlying relationships. So the approach that my solution has developed, which I'll be talking about, is create a graph causal model where K1, K2 are the model parameters. So this graph model, as you can see with the input load, shaft vibration will affect the two bearings, bearing condition will affect the other bearing, and they will all kind of add up to get the vibration at the end. So once we have this forward simulation model, I use, this is especially for engineers, a very comfortable picture. This is what control system means, Kalman filter, state space data model and so on. So that's the technology behind it, and it's been married with simple neural network, multi-layer, so it's not deep learning or anything. But there are some tricks. There is a final stage, which is actually that graph model, and back-propagating error across that is a little tricky, but not particularly difficult. Somebody can do that derivation, or I've done it and happy to provide. I won't go through, this is one of the results, just to show you when I actually physically change this coupling from 0.1 to 1, and you can see it is beautifully tracked and captured. There is noise, this is a stochastic time series, so it's not simple to do these things. But this system will do that. And I have actually a recipe for it, which is, when your plant is, it's our term for anything, an asset, which is a machine, or a system, which could be a FSM, flexible manufacturing, FMS, manufacturing system, and so on. You absolutely need to work with the domain expert. And that's how you create that graph model for it, causal graph. And then this is too much detail. This actually talks about that construction. How do you actually go step by step and get the P, the plant's parameter value, which is approximated by Q. So this is how the solution ends. Now, just talking theory is not enough. So there is a business model for it. I call it a two-sided marketplace. Two-sided marketplaces are things like Amazon, sellers, buyers, or Uber, drivers, riders. So here it is manufacturing OEMs, people who make motors and pumps like ABB, Siemens, and Hitachi and others. On the other side are factory operators. So this two-sided marketplace, one way of making this available and actually a very good business is to then create this two-sided marketplace where they will place and we will help develop the inverse model. So this is like a software stack for it. And factory operators can take it and instantiate each of their machines. There'll be hundreds of pumps and motors on a plant floor. That'll be automatically done because this is all adaptively learning in real time from the real-time vibration data. And then we can provide some what-if analysis service and revenue can be generated. So I'll conclude by saying I'm currently involved in what's called, we have a large 5G lab in Seattle with all the industry and government partners. And I'm in the process of trying to create a causal digital factory. And I would encourage you to join. And this is a good time because 5G's initial thrust is going to be industry. And it's not for consumer use that much. So that is an appropriate time to proliferate causal digital twin. And I hope you will join my crusade. Thank you very much.
Thank you.
Automatically generate ML models using Azure Machine Learning Service, specifically automated ML. So before we begin, I would like to introduce myself. I'm Aniththa Umamahesan. I'm a program manager on the AI platform team at Microsoft, and I work on automated machine learning, which is a topic we're going to discover today. So looking at the agenda, we'll start off by looking at a glimpse into what Azure Machine Learning is. We'll discuss why automated machine learning. We'll dive into the capabilities. I have a demo for you using our automated ML UI, and then we could go over what you could expect during the actual conference. So let's look at the normal machine learning process. What happens is normally you'll have a machine learning scenario. So you want to figure out the price of a car or predict the house prices. And you'll have that stored in some sort of data, which is going to be stored in a blob store or a data warehouse. And once you have your data, you're going to prepare the data. So this is the part where you clean the data. You might do some missing value imputation, drop some columns. And once you're happy with the state of your data, you go to the stage where you build and train a model. And normally this takes several iterations until you find that optimized model, which you want to either deploy or download, customize further. So let's go ahead and take a look at a machine learning problem. Let's figure out how much this car is worth. And for this example, let's just say we're going to predict on the metric accuracy. And since we are figuring out the price of the car, we'll need to determine which features, which algorithm and parameters to choose. So let's just say we go with mileage, car brand, and year of make. Maybe gradient boosted as our algorithm, and maybe tune our parameters like this. And this returns a model of 30%. Looking at that, we know 30% accuracy is definitely not good enough. So maybe as a data scientist, what I would do is choose different features, choose a different algorithm, and tune my parameters differently until I get a model of 50%. I know this is a little better, but I know I could definitely do better. So normally what I would continue to do is iterate, choose different features, choose a different algorithm, tune my parameters until I find that optimized model of 95%. As you can see, this process is definitely time consuming, and there must be an easier way to do this. And that's exactly where automated ML comes in. With AutoML, all the user needs to do is bring their data set, set up some configuration and constraints. So let's just say you're going to do a classification task or a regression task. And then you'll need to specify like the metric you're going to optimize on, say maybe accuracy or AUC weighted. And then once you have those constraints set, we go ahead and do the feature engineering for you. Normally this takes hours. Now it's going to be done within minutes. And then we pick and play, choose an algorithm for you, tune your parameters, and return the optimized model for you in our leaderboard. So automated machine learning, it basically picks an algorithm and hyperparameters for you and generates a model ready for deployment. The model then can download.
Anitha, sorry to interrupt you. The slides are not moving.
Oh, is it moving now?
No, not at all. It is the same thing. You probably have to go and click on each on the left side that you have.
Which screen are you looking at right now?
We are looking at the first one only.
I see. You're still on this one.
Now we see your picture.
I see.
That's okay. Good. That's what you have to do. You're doing a good job now.
Okay, so I think the display.
Okay. Go and click on the appropriate slide that you'll be talking about. On the left, automatically shows on the right.
I think I'm sharing the wrong screen. That's why.
Okay. Whichever way.
The screen went off.
We lost it. Yeah. Okay, it's probably coming back.
Seeing now.
Hold on. Yeah, now we can see what is automated machine learning.
Okay, I'm going to go back a couple slides.
Yeah, do.
Yeah, sure. Yeah, you can.
Okay, looks like this is frozen.
And not yet. We lost it again.
Yeah.
Now, what you had is okay at that time. All that you have to do is click on the left, right? Yep. Which one you want to do, and progressively you can see both versions.
Let me do the screen share. Okay, hold on.
Okay, let's see. What should we see?
Slide.
Okay. We see model creation is typically.
Okay. We'll start off from this library. I'll start from here. Does that work?
Okay. Machine learning process.
So yeah, looking at the normal machine learning process, we normally have our data stored in like a blob store data warehouse, and then comes a step where we prepare our data. And then comes the several iterations of building and training our model until we find that optimized model. And then we go ahead and deploy the model. So as I was talking about earlier, let's look at this specific example. We'll figure out how much this car is worth. So in order to do this, we'll need to choose features, algorithms, and tune up our parameters. And since we're figuring out the price of the car, we'll go with car brand, mileage, and year of make. Maybe choose gradient boosted as our algorithm and tune our parameters like this. And this returns a model of 30%. As we know, this is not good enough. So normally as a data scientist, I'll probably choose a different feature, choose a different algorithm, tune my parameters differently, and this time I get 50%. I know this still isn't the best model, so I'll continue to iterate until I find that optimized model of 95%. So as you can see, that process is definitely time consuming, and there has to be an easier way to do all of this. And that's exactly where automated ML comes in. So with automated ML, all you need to do is bring in your data set, set up your configuration and constraints. So you can specify if it's a classification, regression, or forecasting task. Choose a primary metric you want to optimize on, and maybe set up some constraints like you want to just run the experiment for 1 hour rather than 3 hours, or you want to exit the experiment after it reaches a specific score. And then comes a step where it does feature engineering for you, and then it'll pick and play and choose an algorithm, tune the parameters, and return the optimized model for you in the leaderboard. So what automated machine learning is, it picks an algorithm and hyperparameters for you and generates a model ready for deployment. The model then can be downloaded to be further customized as well. So let's go over the mission statement. So our mission is to enable automated building of machine learning with the goal of accelerating, democratizing, and scaling AI. And you might wonder what that actually means. So let's just say you have a data science team with varying levels of experiences. With AutoML, you are able to expedite this entire data science process. So this is where the democratized AI piece comes in. Now, if you have a smaller team of data scientists, with automated ML, you're able to make the most out of the limited resources, thus improve the productivity of the data scientist. And we've also seen scenarios where customers want to build multiple machine learning models in parallel. And now they can do that in an automated way. So that's where the scale AI piece comes in. So that's why our goal is to accelerate, democratize, and scale AI. So automated machine learning is based off of Microsoft research. So the brain has been trained with several millions of experiments, and it's very similar to a recommendation system. So if you've used Netflix before, after watching a couple movies, you might realize that it's recommending the movies that you would actually want to watch. And that's exactly how our models are being recommended. And currently we support classification, regression, and time series forecasting. And what's great about AutoML is that it doesn't look at your data, so privacy is maintained. We only look at the metadata. So just to go over the entire flow, we start off with the whole data pre-processing step. So we clean up your data, and then comes the feature engineering step where we, normally this is like a very time consuming step, which now can be done within minutes. We pick and play, choose the algorithm, we tune the parameters for you, and then we recommend a model for you where you could then go ahead and interpret and get some explainability from our dashboard. So I want to highlight that machine learning is for everyone. So let's just say you want to just get started. If you are a data scientist, you might feel comfortable using one of our Python SDK in the Jupyter Notebook, and you'll be able to use the Jupyter Notebooks right from our Azure Machine Learning Service. If you're a citizen data scientist, or if you just started making your way as a data scientist, or if you prefer graphical user interface over coding, you can use the automated machine learning web user interface, and I'm going to demo this in a minute. And you could start training a job within a few clicks of a button. If you're a data analyst or a business analyst or a data engineer, you can use our integrations with Power BI. We have Alteryx and also SQL Server to train and predict directly from the tools that you're already using on a daily basis. And if you're a developer, you can use automated machine learning in Visual Studio with ML.NET Library, or you can code directly with Python. So as you can see, machine learning is for everyone. So I'm going to do a quick demo using our automated ML UI. And for this example, we're going to use the authoring experience from automated ML, but you're also able to run it using our notebooks. So I'm going to go ahead and click on automated ML here. And then I'm going to click on new automated ML run. But you could also see the previous runs that have been completed before. And for this example, I'm going to use NYC energy. So I'm going to get historical data about on an energy grid and predict the future load. So this is very important because too much energy produced can lead to a waste of energy, and too little can lead to power outages. So you have the option to create a data set from either your local files, data store, web files, or open data sets. I'm going to go ahead and use this data set I uploaded a little earlier. I'm going to click on next, and I'm going to give my experiment a name. In this case, I'm going to name it NYC_energy. I'm going to choose a target column. So this is the column I'm going to be predicting on. And since it's energy demand, I'm going to click on demand. I'm going to choose compute targets, which is automatically going to scale to my experiment needs. I could create a new one, but I'm going to go ahead and use something that I already created just for demo purposes. And then comes a part where I need to choose a task type. So automated ML currently supports classification, regression, and time series forecasting. This example is a time series forecasting. And then since it's a forecasting task, I'll need to choose a time column, in this case, timestamp. And then there's some additional features that you could definitely explore. We'll explore this during the actual conference. For now, I'm going to go ahead and click finish. And what Automated ML is going to do is intelligently test multiple models in parallel and return the optimized one for us. So while this run launches, I'm going to go ahead and open up a run that completed a little earlier. So this one over here, as you can see, it's completed. Let's click on the run ID. And what we can see over here is the recommended model. So in this case, it's Stack Ensemble. And we see the metric value for the primary metric, normalized root mean squared error. If I'm not satisfied with this model, I could go ahead to this models tab over here and explore all the other models that were tested during this run. So I'm going to go ahead and click on Stack Ensemble, for example, here. And although I got this primary metric value over here, I could also explore the other metrics from this tab over here. So I can see the run metrics for explain variance, for mean absolute error. And this could help me understand if this model is good enough for me or not. If I need more information, I could go ahead and click on the visualizations tab. And this generates some information about the model performance. So for example, I could look at this predicted versus true chart and see that this actual model looks actually pretty good. And if I'm happy with it, I could go back to the model's details page and go ahead and deploy the model. And we could do that quickly as well. Let's just call this NYC Energy. And then I get to choose if I want to deploy this into a testing environment, ACI, or a production environment, AKS. For this example, let's deploy it to a testing environment. And all I need to do is click deploy. And what's great about Automated ML is that it tracks all the assets created along the way in this asset section. So I could go ahead to this data sets part, and I see my data set is actually still saved here. My experiments are all saved in the experiments tab, so we can see my NYC Energy one. So the models automatically gets registered when I click deploy. So this NYC Energy was registered here. And I can see all my deployments made in the endpoint section. And you can see this NYC endpoint. So that's basically Automated ML in a nutshell. We're definitely going to cover more during the actual hands-on workshop, and looking forward to seeing you all there. So that's all I have for you guys for today.
Thank you a lot. And we like the way you went into details, hands-on, learning for the attendees.
The verticals that we consistently work in is first one is our charity and donation. It's a 100-year complete this year for us. We sponsor the affected areas with natural disasters in our charity and donation division. The second one is the insurance. The third one is investment. And the fourth one is advisory. For the investment, we have acquired Boston Advisory just 2 months ago. Insurances, we have about 2.2 million customers. And into the investment, we have about $25 billion investment portfolio with us. Okay. Within that respect, we have a new CIO, and the new CIO decided to transform the entire IT information systems division into the more digitalized way, more AI, ML driven approaches. Now, the challenge with our industry is that we are regulated industry, right? So the AI, ML is very lucrative to us. We want to have a new customers, and we want to improve the customer services with the existing portfolio of the products. However, we have identified that there are certain challenges adapting the AI, ML into the regulated industries. And we have the prominent use cases and example that justify our reasons to gauge or measure the risk with AI, ML. So in this presentation, how I articulate it is that why really we see the risk and what are the challenges of AI, ML. Second is that how we are approaching it with the IIG framework. The next one is that what we need to be considering moving forward with the use case, right? And the last one is that where the industry is moving to define the ethics in specific to implying the AI ops or the AI ML into the real digital business operations. Right? Now, to go along with it, I will switching back between this slide and the next slide. Basically, the challenge with us that, yes, we know that there are digital insurances and the marketplace is changing in terms of how you do the different investment and insurances and advisory online, right? There are a lot of competition which 70 years ago, Knights of Columbus were having the kind of a the smaller portfolio of products and services. Now it's huge, and as the portfolio goes larger, you face the more competition, more products, more standards, right? The business processes are literally into the silos, and we are combining the different activity with the business processes, along with the underwriting, claim processing, and other the actuaries and the annuity profiling. All of these are coming along when we are defining our AI strategy. Data, the correctness of the data is not the major issue, but the validity of the data in terms of the digitalization and change in dimensions because of the digitalization. That's the issue. And the technology that we select, because any AI ML tool has their own trade-offs, and it has its own impact when we choose the specific AI ML technology. Now, how we really see these challenges and what we learn from the different the software companies and also into the industry, and including Microsoft, by the way, right? If you look at and search, you see that Google has been sued, and they are under settlement because of the data issues and private information use. Apple, Microsoft, Tesla, Alphabet, Dell, they all are sued for unknowingly participating and profiting from the child labor, right? It was a huge article in the New York Times for the Facebook, right? They are not appropriately handling the documentation and information, so that's a standard issue. Yes, AI ML is very lucrative when you look at the Facebook, and I was fascinated by AI ML when Facebook said, they are sending the ads which is based on my browsing history and the interest, right? But it has the larger consequences, and the entire industry is working towards it, more specifically into the insurance industry, because now the insurance industry is covering your privacy, your cyber security, and your personal portfolio as well, right? And that comes into the play when we offer the insurances into the digital landscape. Okay? Same thing with the Clearview AI to put their footprint there. They have the facial recognition concerns over the different vendors. Okay, and finally the Google, Facebook, and Neuralink, they are being sued for weaponized AI tech transfer in China, right? And the misuse of AI. Now, what we have done is to recognize all of this, all of these issues. We have manufactured the framework. We have introduced the concept of influence index, right? So even though we look at the previous two examples, they are fascinating. They are actually improving the efficiency. However, there is no way to know that what is the limit, and if we are moving into the right direction without violating the people's privacy or the information right. Okay, because the standards are not being defined or partially being defined. They are under construction. There are unknown scenarios, right? So the influence index evaluation engine, it would continuously really recognize those standards along with the different digital business operation. And the bridge between the influence index computation and the digital business operations is the digital business activity manager. So the activity manager defines the acceptance criteria, whether your ML is producing the acceptable results and to the different participant of your entire enterprise, right, including regulators. So we included the regulators into our day-to-day evaluation of AI ML. And the reason being is that in the regulated industry, the advantage is that you are closer to states, right? So for example, NY 510 is really evaluating your impact of AI ML into your underwriting processes, right? So and New York State is involved. City state, so Connecticut state is the main state that we are in. So Connecticut state is every quarterly, they see our results from AI ops and the result of the influence index, right? Influence index is something new to them as well. We have to provide some of the information, but it is available through the dashboard. What influence index do is it would say that how much you are in adherence to the standards regulation, and how much you are advancing in your AI strategy overall. And how it does that is by the scoring mechanism. So we have a positive scoring and negative scoring, right? So in a positive scoring, we advance the influence index, because if there are business domains and there are products and services, there are the AI level of the acceptance criteria is being met, then we go positive in terms of the influence index. But the negative scoring is that if we have to advance some of our the digital business operations or the function underneath those operations based on the regulations, rules, or security concerns, privacy, then we go negative scoring. Okay, so it starts with the baseline scoring, and then we build on top of it. So in the actual presentation, I will go over how we create the graph, and then in about 8 iteration, how we have progressed. Okay. However, this progression, this is all theory, right? The implementation come in a very prominent example of underwriting. So what underwriting is, just a quick note, is that when there is a new customer, we rate the customer based on the different criteria. So IFRS is a new audit standard, and it uses 3 different models to rate the customer and setting up the audit criteria, right? So the rate includes the risk to get this customer onboarded or renew the specific customer. So that risk analysis, we have utilized the AI, and we have utilized the location data, market data, and customer data to identify the risk associated with with that particular customer using the learning workflow or AI ops methodology. The domains are customer, agent, then claims, all of this, and policy admin. Those are the domains that we have defined to articulate the process and the activities. So in a presentation, I will go over the activities, domains, and the impacts of the activities and domains in our AI ops model, and how we gauge the influence index or govern the influence index. Okay. So these are the some of the do's and don'ts in terms of what you need to take care of, what you need to govern in terms of your digital business operations, digital activities, and influence index, our learnings, right? And some of the don'ts, right? So don'ts were very prominent. We have to proactively include the regulators, right? And one of the example, if I go to the next slide, the healthit.go. So essentially, the healthit.go is setting up a standard or advancing the standard 170.315, and that is what that we use, and they provide the certificate to the organizations that how the behavioral, the psychological, and social data can be utilized in your AI model. So when we do underwriting, right, we also consider those data into our model, okay? But they are still advancing it, because they are still advancing in terms of where to use and how to use those data into your day-to-day life, right? So that is the number of standards that we are watching on a regular basis to advance our influence index governance processes and the criteria, basically the paradigm to measure the influence index, right? So the biggest thing is that as this standards advances in terms of the AI, we are ready to accommodate or extend our governance model and the computation of the influence index at runtime. So those are the key takeaways, that it becomes extendable, and we are always on a watch out for, we are not violating any regulation that would end up into the reputation loss and the hefty fees by the compliance and regulators. Yep. Yeah.
You
so,
finished? You're going for? I didn't hear you.
So I'm pretty much done. So what I was saying, that I would go into the detail of how we have implied this influence index factors into underwriting during the actual presentation. This whole diagram, I would go into the detail.
Fantastic. Anything else?
Yep.
You're done?
Yep.
Okay, just want to make sure. I didn't want to interrupt when you were doing. Now we had 3 experts in the industry routinely managing thought leadership as well as implementations from different companies, different type of organizations, from Knights of Columbus to the digital tool concept and the excellent hands-on presentation made by Dr. Aniththa Umamahesan. And we have one set of questions that has come through the chat rather than Q&A, and you are all welcome to go there. So that I'm going to read is the same person who has asked the question. So I'm going to read very quickly so you can respond, anyone can respond. And what are the functional business needs that are driving the organization toward AI? What kind of projects are being executed? I think you have covered some of these things. If you want to clarify, please feel free, any of the speakers. That's the question coming from one of the person in Seattle who probably will be attending the event. Any responses?
Well, it's a very broad category.
I know, that's why I said.
So to quickly, just a couple of words on it. Anything that is repetitive. So I was attending this AI for Business course offered by MIT Sloan. So the formula they were saying is the first thing to look for is any repetitive task. You abstract it away. AI, ML, that's the first effort that you have to make. Now, so the other extreme where you do not try to, there is human judgment, personal emotions, and various things that are involved, strategic decisions, probably not smart to automate. I mean, this at a very high level, but I'll leave it for others to add to this.
Yeah. Anything else? Anyone else? Okay, let me go into the next question, at least with the samplers. The same gentleman has asked from Seattle. And what are the 2020 priorities for these companies? And what are the career opportunities for someone who wants to start a career in AI functional, as an AI functional consultant? You have 3 samples of companies' presentations. If anything that you want to say, please go ahead and respond to him. Career opportunities. AI functional. Okay. So now let me just make a general comment here. You just got 3 examples of topics, even though the topics are subjects for themselves, presented by the 3 expert speakers who are practicing themselves. that's something that you can think about, right? You can be in the nonprofit, you can be in the high-end thought leadership of what could be done, etc., to convert from IoT data to any of the instrumentation data into digital twins, which is very important for the causal approach to the AI. Right? And so you can pick whichever you want, but you will have close to 80, 50 to 100, depending on which conference, which location, expert speakers. And we cover variety. And just watch out for the April agenda that will be on the website when you go there. It's not still filled up. And look for it. And if you have anything particularly that you want to do not hesitate contacting us, right? And I'm KRS Murthy. I'm the conference chair for these conferences from the beginning to the thing, but I focus mostly on the Silicon Valley events, don't go to other locations. But you can always approach me. bigdataexpert@gmail.com is one of the emails. globalaIexpert@gmail.com without E, just XPERT. And feel free to approach Lena. He will direct you to the right people and so on. So we want you to attend, and you get a 20% discount if you use the code webinar for the conference. So feel free to up to February 14. Now, do you have any questions among yourselves, any additional point that you wanted to make? Because we still have about 3, 4 minutes, 5 minutes time. Speakers? Looks like no one has any, but they've done a great
I think
job.
we can close. Yeah, we'll end it.
Yeah. And so feel free to contact Lena or me as well. And she will direct if you put my name there. And I can be of any help to the attendees, to the speakers. And then I would be jealous of if you go only to Seattle and speak, come over to Silicon Valley, which is also going to be a bigger conference. We did one